Okay, today we're going to talk about trend lines and predictions using scatter plots. When a scatter plot demonstrates a linear relationship, a straight line can be drawn to show the overall trend of the data. This is a lot like a line of best fit, and in most cases we use the same line for line of best fit and trend lines. Trend lines are talking more about what you can predict. Trend lines can be helpful in making predictions about future or missing data. A trend line must be a straight line that lies as close to the center of the data as possible, and that's where the line of best fit came in. Okay, so we're going to practice our trend lines. In our first one, I drew this line. And when I drew it, I wanted to make sure that I had approximately the same number of dots on each side of the line to get it as centered as possible, just like we did with our line of best fit. Okay? When I'm looking at this, if I were to predict something, I would know about what range to find a point. Okay? If I look at this next one, this one has an outlier that's laying way out here in the middle of nowhere. And then it has this nice group here that obviously has a negative correlation to it. I would call it linear because it does seem to be following a straight line. It's not as scattered. And so if you take and draw your line straight down through there and have about the same on each side, then you've centered it. Okay. Our last one is this one here, and I drew two lines. I first drew the blue line, and I realized I had more dots on this side of the line than I had on the bottom side of the line. So I redrew a red line, and that seems to center it more. So that red line is a better line of best fit. Okay? All right. Then we have this one, and they have some questions for us to answer. So when I take a look at it first, I notice I have two clusters. I have a larger cluster, and I have a very small cluster. They want to describe the association of the scatter plot. I feel that it's negative and nonlinear because see how these are more scattered out, whereas above these kind of follow that line a little better. So I feel like it's nonlinear. We can still use the information to predict the value of y when x is 13. If I come over here to where x is 13 and I come up anywhere in this red zone, I would expect to find a point. And I kind of went with what's right in through here. So it's about 60, 65. So anywhere between 60 and 70 is probably what we would find. Okay. Then they want us to predict the x when y is 50. So if I come over here and I look at my y is 50, and I come over to about where we would see the others, we can figure that then my x is probably going to be around 17. Okay. Now I see my next one, and I again have two clusters. I have a smaller cluster here, and I have a larger cluster here. This is a little more elongated. I do feel like this one is linear because it does seem to cluster around a line when I drew a line through both of the clusters. So I said that it was positive and linear. Then they wanted to predict how tall a 15-month-old giraffe would be. So a giraffe at 15 months is here, and if I came up, I figure where my line is about in that space right there. So that would be about 13 feet tall. And they want to know about how old would a giraffe be if they were 20 feet tall. So if you come over from 20 to meet this line, it comes all the way out to past 30 months. So let's say, 39, no 30, so about 33 months. Okay. Then we're going to take a look at a few examples that we have. Okay. So we have a line of best fit on this one. You'll notice how short the distances are from the points to the line. Because it's short and close to the line, we consider this to be a very good line of best fit. It is fairly centered in the data. And I would also consider this to be linear because it does seem to closely follow the line. If I look at the one next to it, you'll notice that there's a lot larger distance between the line and the points. So this one is probably not the best line of fit because it's not really centered very well. Okay. On the next page, they have this graph right here. And if I were to find the line of best fit or the trend line, I would, first thing I do is to look to see what direction. It looks like it's going to be a positive. So I'm going to bring my ruler and I'm going to try to find the center where everything seems to be fairly closely lined. And I feel like this line right here might be our best bet. They're not very far apart from the line. This one here is probably a little bit further than the others, but the others closely follow that line, so that would be a good line of best fit. When we're predicting, we can find different information, and there's two types. There's interpolate, and that's when you're making predictions for values that fall within the plotted values. So if I were to take that same graph and I were to look at where the data starts and ends, and that section between here and here, that if I were to guess between there or predict within those ranges, that's interpolation. It's within the plotted values. So I have something there I can use to interpret. Okay? So that's interpolate. The other one is extrapolate. Extrapolate is when you're predicting values that fall outside the plotted values. So if you have to be more careful when you're extrapolating. The further away from the plotted values that you go, the less reliable that data can be. So you'll see in this one it has highlighted between so that it's outside. Anything within the red areas is considered to be extrapolation. Okay, so you have to be careful with those because it's just not as reliable. Okay, you have homework. If you have any questions, please make sure you reach out. Thank you.